Welcome, Form 4, Physics, Topic 5, Waves, Notes, Lesson 4. You must have watched Lesson 1 until Lesson 3 to understand Lesson 4. We continue on vibration. Now today, we are going to look the vibration of a simple pendulum. I've shown the diagram of a pendulum. We have a string or rope tied to a mesh. This mesh is what we call a bob, and it has mesh. The bob has mesh, symbol M. And this string has the length, I put symbol L. The string has length, symbol L. And this bob here, it will vibrate between two fixed positions. So it's starting from our equilibrium, it goes to positive amplitude, return to equilibrium, go to the negative amplitude and return back. Okay, now this simple pendulum has the formula of frequency. What is frequency? Previous lesson I've already explained. And for this simple pendulum, we have a special formula for frequency, which is the frequency is equal to 1 over 2 pi square root G over L, where G we already know. The G we learned in Form 4 is gravitational acceleration. The G is gravitational acceleration, and its value G was 9.81 or 10 ms negative 2, whereas the L is the length. Now we know that previous lesson that period is 1 over frequency. So from the formula frequency, if I invert terbalikkan, I can get the formula of period. Because period is 1 over frequency, I invert the formula of frequency, I get the formula of period. So here 1 over 2 pi, it becomes 2 pi over 1, which is 2 pi. The square root maintained, G over L becomes L over G. In SPM, the formula period is more important than the formula frequency. Now, from this formula of period, we will get the factors of period. Okay, how? Simple. The period and the L, up and up is proportional, and up and down is inverse. So in any formula, we can get the factors, any formula, whereby up and up is directly proportional, up and down is inversely proportional. So now we have that the period is directly proportional to the square root of L. Period is directly proportional to the square root of L. And also the period inversely proportional to the square root of G, which I have written here. Period is inversely proportional to the square root of G. Now in questions, they don't like to use square root. Here also square root, we don't like to use that. So what we do, we square both sides. So period directly proportional to square root L. Square both sides, we will get period square directly proportional to L, the length. And over here also, the period inversely proportional to square root G, square both sides, I'll get period square that inversely proportional to G. In SPM, the one important is the factors of period and L. This is the important one. This. Most of the question based on this. That is, the period square directly proportional to L. And in Form 4, topic 1, anything directly proportional, the graph would be, so if I were to draw a graph, period square versus L, period square versus L, it will straight line through the origin. Whereby, now we are going to look from this graph, period square versus L, what is the gradient of the graph, period square versus L? This gradient of this graph, T square versus L, has a meaning. Now we take the formula, period, which is T square equals 2 pi square root L over G. I square both sides, so it will become T square. 2 pi square will become 4 pi square. And of course, square root, you square cancel, we will get L over G. I'm just going to rearrange the T square, I write back. The 4 pi square over G, I collect together, 4 pi square over G. And then the L, I put separately. And this, because it is a straight line, so the graph must be y equals to mx plus c. Because it is going, the graph is going through origin, so the c, y-intercept is 0. The y-axis is of course t square. The x-axis is of course L. The y-axis is t square. The x-axis is L. Therefore, the gradient m is 4 pi square over G. This is the most important. The gradient of the graph is 4 pi square over G. Okay, which means the gradient of the graph is 4 pi square over G. Which means if you draw the graph T square versus L, a straight line, and you calculate the gradient of the graph, we can find the G, gravitational acceleration. We can find, you calculate the gradient of the graph, straight line, 4 pi square, we know the value. We can get the value of G. That is the main purpose of this graph T square versus L. Now since F frequency is 1 over T period, okay, since frequency is 1 over period, that means the frequency up, period down, it is inverse. As I said earlier, up and down, it must be inverse. From the formula, F equals 1 over T, F is up, T is down, up and down is inverse. That means the frequency is inversely proportional to period. Now what does this mean, inversely proportional? It means the factors of T is opposite of the factors of F, because F and T is inverse. So the factors of T is opposite to the factors of F. Just now we already learned that the T is directly proportional to square root L. So if T is directly proportional to square root L, that means F is inversely proportional to square root L. If T is directly proportional to square root L, the frequency F is inversely proportional to square root L. And just now we learned that the T period is inverse to square root G. The factors of T opposite to the factors of F. So therefore now, F must be directly proportional to the square root of G. So the factors of F, frequency, is frequency inversely proportional to square root L and frequency directly proportional to square root G. Okay, on the next lesson, we will be doing vibration of loaded spring on the next lesson. Thank you.